Shortly before noon, beneath a sky that appeared entirely ordinary by the standards of the 19th century, the sun revealed a power humanity had never witnessed before. There was nothing in the air to suggest what was coming. No sound, no visible explosion, no tremor beneath the ground, no shadow crossing the land. The day unfolded as any other, calm and unremarkable. And yet, far beyond human perception, a transformation had already begun. Deep within the sun, invisible forces were rearranging themselves, magnetic fields twisting, tightening, and snapping with unimaginable energy. Within hours, the most powerful natural force ever recorded would be moving silently across the vast emptiness of space toward Earth, unseen, unstoppable, and completely indifferent to the fragile lives below. What unfolded between the final days of August and the early days of September in 1859 would later become known as the Carrington Event, the most intense solar storm in recorded history. A phenomenon that quietly exposed the vulnerability of civilization long before humanity understood how deeply it depended on delicate systems of technology. In the days leading up to the event, between August 28th and September 2nd, astronomers noticed an unusually large number of sunspots spreading across the surface of the sun. To the naked eye, these dark blemishes appeared harmless, almost insignificant, but to those who studied the heavens they hinted at something deeper. Sunspots form where immense magnetic forces pierce the solar surface, regions of instability where the sun's energy becomes trapped and distorted. Today they are recognized as warning signs of violent solar activity, but in 1859 their meaning remained largely speculative. They were carefully drawn, catalogued, and discussed in scientific circles, yet their implications were not fully understood. The sun had shown signs of unrest before, but never in a way that suggested global consequences. On August 29th, the first subtle warning reached Earth. Auroras appeared far beyond their usual polar boundaries, illuminating skies in regions where such displays were virtually unknown. In Queensland, Australia, observers looked up in disbelief as the night sky glowed with shifting colors. Similar reports emerged from other distant locations. To many, the lights were beautiful, mysterious, even spiritual. Some believed them to be atmospheric phenomena, others divine signs. Few realized that these glowing skies were not the event itself, but merely a whisper of something far greater already racing toward the planet, carried by forces no one yet understood. Shortly before noon on September 1st, 1859, two English amateur astronomers, Richard Christopher Carrington and Richard Hodgson, were engaged in what should have been an ordinary observation of the sun. Working independently, each projected the solar image onto a screen, carefully tracking the familiar patterns of sunspots. Their work was meticulous, methodical, and routine. Then, without warning, both men witnessed something unprecedented. A sudden and intensely bright flash of white light erupted from the solar surface, startling in its clarity and brilliance. It was so bright that Carrington initially believed sunlight had entered his telescope by mistake. But the light persisted, unmistakable and undeniable. In that moment, history quietly shifted. For the first time, a solar flare had been directly observed by human eyes. Solar flares release staggering amounts of energy in mere minutes, heating solar plasma to extreme temperatures and accelerating charged particles to extraordinary speeds, sometimes approaching the speed of light itself. The energy released in such an eruption can exceed that of billions of nuclear bombs combined. Yet even this astonishing flash, visible across the face of the sun, was only the beginning of a much larger and far more dangerous process unfolding beyond human sight. What followed was a massive coronal mass ejection, an immense cloud of superheated plasma violently expelled from the sun's outer atmosphere. This cloud, composed of atoms stripped of their electrons and rendered electrically charged, carried with it powerful magnetic fields capable of reshaping planetary environments. Propelled outward with extraordinary force, the ejection surged directly toward Earth. Under normal circumstances, such clouds take several days to cross the 93 million miles separating the Sun from our planet. This one completed the journey in just 17.5 hours. Scientists later theorized that an earlier solar eruption, responsible for the auroras seen days before, may have cleared a path through the solar wind, allowing the 1859 storm to travel with unprecedented speed, as though nothing stood in its way. When the storm reached Earth between September 1st and 2nd, the planet was struck by one of the most extreme geomagnetic disturbances ever recorded. Earth's magnetic field, an invisible shield that normally protects life from the charged violence of space, was violently compressed and distorted. The magnetosphere shuddered under the impact, allowing energetic particles to pour into the upper atmosphere. The effects were immediate and global. Auroras ignited skies across nearly the entire planet, extending far beyond their usual confines. From the polar regions to the Caribbean, from Cuba to Hawaii, the night sky burned with shifting curtains of light. In the Rocky Mountains, the illumination was so intense that miners awoke in the middle of the night, convinced that dawn had arrived. Believing morning had come early, they rose from their beds and began preparing breakfast. Elsewhere, animals became restless, confused by the unnatural brightness. In cities and towns across the northeastern United States, people stepped outside in disbelief, reading newspapers beneath the glowing heavens long after midnight, guided by a light brighter than moonlight and far more unsettling. Streets that should have been dark and silent were bathed in color, shadows stretching unnaturally across the ground. Although the world of 1859 lacked the technological complexity of the modern age, the storm still left its mark. Long-distance communication relied almost entirely on telegraph networks, systems that transmitted information through electrical currents running along miles of exposed wire. As the geomagnetic storm intensified, these networks began to behave unpredictably. Telegraph systems across Europe and North America failed without warning. Wires sparked violently. Telegraph poles released visible electrical arcs into the night air. Operators described hearing crackling sounds and smelling ozone as equipment seemed to come alive on its own. Some telegraph operators received electric shocks even after disconnecting their power supplies. In several cases, paper caught fire from the heat generated by uncontrolled currents. Yet, in one of the most extraordinary consequences of the storm, certain telegraph lines continued to transmit messages without any external power at all. Operators discovered that they could communicate by disconnecting their batteries entirely, allowing the storm-induced currents flowing through the earth itself to power their machines. For a brief moment, the planet had become part of the circuit. Newspapers struggled to describe what words could barely capture. On September 3rd, 1859, the Baltimore American and Commercial Advertiser portrayed the aurora as a magnificent and otherworldly spectacle, likening the sky to a luminous cloud spread across the heavens, through which the brightest stars shone faintly. The light, the paper reported, was brighter than a full moon, yet possessed an indescribable softness. It cast long shadows across silent streets, bathing the world in a glow that felt both beautiful and deeply unsettling, as though nature itself were revealing a hidden truth. Despite its intensity, the 19th century world endured. Society had not yet bound itself to electrical grids, satellites, or digital networks. There was no global infrastructure to collapse, no interconnected systems upon which every aspect of life depended. The storm passed, the skies darkened once more, and daily life resumed. But the Carrington event left behind an unanswered question, one that would grow heavier with each passing decade of technological progress. Modern research suggests that solar storms of this magnitude may occur, on average, once every 500 years, while less severe events are far more common. In 1989, a geomagnetic storm collapsed the power grid of Quebec in just 2 minutes, plunging millions into darkness. In July 2012, a solar storm comparable in strength to the Carrington event was observed, but its trajectory narrowly missed Earth by a matter of weeks. In 2013, researchers estimated that a similar event today could cause between $600 billion and $2.6 trillion in global economic damage, disabling satellites, disrupting navigation and communication systems, crippling power grids, and undermining the digital foundations of modern civilization. The Carrington event was not merely a celestial spectacle, nor a historical curiosity confined to archives and textbooks. It was a warning written across the sky. The same star that sustains life on Earth also holds the power to disrupt everything humanity has built. The question that remains is not whether such an event will happen again, but when, and whether we will be ready when the sky lights up once more.